in good shape. Oh my God.
Welcome to day 4. So far, ground lessons 1 through 8 complete. Now we do ground lesson 9, and following ground lesson 9, we complete the stage 2 exam. Another opportunity for us to get in there and kind of check our learning and see where we're at. Okay. All right. Ground lesson 9 is interpreting weather data. We just got finished with weather. Remember, ground lesson 7 was weather theory. So interpreting weather data now is what kind of reports come at me from the reporting sources? What type of reports are available for me, and how do I interpret that information? It's presented to me in a certain manner. We look, for a little while how forecasters develop an idea and develop the premise behind which way weather might be trending or what kind of expectations we should have in the very near future. And then we take a look and see where can I get the information and how do I read it. Okay? This comes from the Guided Flight Discovery Chapter 7 and also Pilot Handbook of Aeronautical Knowledge, Chapter 13. Advisory Circular 00-45. Do you remember that the other advisory, so I've asked you to take a look at about 3 or 4 advisory circulars so far. And so far, one of them was 16 or 18 pages, the one about non-towered fields. One of them was weather theory, the advisory circular 00-6 Bravo. I said, that one's kind of interesting, and I want you to read it. It was recently updated in 2018 after 30 years of not being updated, so that one's kind of neat. This one it's about 400 pages long. It is truly a reference book, okay? And I'll go through how to use that exactly the way it was intended as a reference book. Now, on the other advisory circulars, I would tell you exactly what update they were on. 45 updates a lot. It updates several times a year sometimes. So right now, I think the most recent one is Advisory Circular 00-45H with change 2. And that's why I said I think that's the most recent one. That's because I haven't looked on the internet today. Okay. So go to the website, make sure you're getting the most current and up-to-date advisory circular. But it's a very useful tool in finding my way towards gaining information and insight on these weather reports when I'm not sure what they're trying to communicate. Because a lot of the information is coded, and if I don't have a way to decode this, there's no way for me to understand what's going on there. All right, Section A, the forecasting process. Yay, look at that. We only got a few key terms. All right, not too bad. All right, so you got persistent method, trend forecast, climatological forecast, analog, meteorological, and numerical weather prediction. Okay? Basically, this entire slide and the very first part of this is just an advertisement on how NOAA and how the National Oceanic and Aviation or Aerospace Administration obtains and gathers weather data and then forecasts to see what could occur, what they expect to occur in the near future. Now, they make observations, and those are in the forms of either ground-based facilities that mostly are automated or real-time data reports from pilots or weather radar that will describe where the precipitation exists. Okay? Something that's observed and is now in the past. It might be recent, and it usually is. Typically, it's no more than an hour old. All right? You can glance back. You can get several hours worth of reports so that I can see, well, maybe if I look at a report now by the persistence method, I look out the window, I expect the same weather to persist. I expect that, yeah, this is going to continue to last. Or I can say, over some period of time, I expect there to be a trend. The weather was continuously getting warmer over this last couple of days, so I expect that to continue to be the case. So they use these observations and then they turn those into forecasts. Out of all the different observations that they have, a lot of the observations come from satellite vehicles in low Earth orbit and even geostationary satellites that constantly measure temperature and pressure through infrared soundings. And they constantly measure and provide that information back to the surface so that these forecasters can give you very, very detailed information. When I tell you that the weather forecasts are extremely accurate within the next 6 to 12 hours, that's not an exaggeration at all. You can expect to see whatever you're finding on your aviation digital data reports, you can expect to see that those conditions are going to occur. Okay? It's not often that they're off completely. And they continue to update. So they might put out a 24-hour forecast, and then within the next 6 hours, they're going to update and go for the next 24 hours. So it's a continuous improvement as well. All right, so here you got observations, and this is just generating weather data. Some sort of process, and they take the information, the raw data. They have computers intermixed with some sort of human effects or some sort of human factors there. And then they disseminate it. How do they disseminate it? Through a whole bunch of different sources. This is hands down the primary and the best, the most reliable, and the most legal way to get your weather report or your pre-flight briefing. Is right there in that 1-800-WX-BRIEF. Okay? How many signed up last night? Or this morning? Hey, all right. Yes, one at a time. All right, here we go. Now then, take a look at what happens through a snapshot. If I'm taking a flight and I know that I'm going to take a flight next week, what am I looking at for weather? Not much. Not much at all. I will spend at most 5, maybe 10 minutes if it's a long flight and going somewhere that might have some challenges that I know about already, usually by topography. So if it's a week away, I'm looking at major movements of these air masses. Where do my low pressures exist? Where do my high pressures exist? What's going on in my source regions? So it says you got monthly and seasonal forecasts. I might know or have an idea of what's going to happen. It's cold every year in Moscow in February. Okay, well, it usually is, right? This year happened to be very warm. Thank goodness. Okay, so this year happened to be very, very warm. Well, they put on their monthly and seasonal forecast, but you can see how much that changes as a standalone product. 10-day forecast, they do a pretty good job at estimating average precipitation and temperatures up to 10 days ahead. Where's that information coming from? Where's my low pressure? Where's my high pressure? Where are the winds moving? Where are the source regions? Is there any humidity fed into these things? And can I expect to see precipitation? So I can gain an oversight just by looking at the raw data product, and then I can also get what the forecaster put into it and find out what they think over the next 10 days. 5-day forecast. We're starting to get some pretty reasonably correct information at 5 days. Weather events such as large storms, major heat waves can be accurately forecast up to 5 days in advance. In other words, something that would completely wipe us off the map or something that would change our plans in a major way, I'll know it 5 days ahead of time. Up to 48 hours, major changes in daily weather can be predicted relatively accurately. Major changes meaning, do I expect to have thunderstorm activity or not? Do I expect to have light to moderate or heavy or extreme precipitation? Do I expect to see any certain types of precipitation? Rain or snow or sleet or hail? I get that 48 hours ahead of time. So now, big chart, I get it, but this gives me plenty of time to stay ahead of this while I'm doing my flight training. You know, I should be constantly somewhere on this chart. And usually, from my standpoint, I'm thinking, I'm in this region always. I don't need the flight instructor to tell me to watch out for those 5, those 4, those 3-day forecast weather reports before I get to the flight. I'm looking 3 days ahead. So then the next day I'm looking 2 days ahead, and I got a pretty good idea what's happening there. The day before, I got, well, in 12 hours or less, predictions of weather including within a 12-hour time period are the most accurate. Severe localized storms may happen, but severe localized storms are usually small comparatively to the air mass, and they usually move fast. That's why they weren't predicted in the first place. So 24 hours away, I know exactly what's happening. If it's right now 9 o'clock at night, and I know I have an 8 o'clock tomorrow morning flight, no doubt I got a great amount of tools to help me figure out what's going on tomorrow. So just make sure you're staying ahead of that. That's my recommendation.
We have these classes in SkyEagle Aviation Academy. Check out please our website www.atp.academy for details.
Now, section B, talking about printed reports. What information do you have on that WX brief? Well, here we go with our key terms. METAR. A METAR is an hourly report. It comes out about 5 minutes before the top of the hour, every single hour, and it won't be more than an hour old. If something major changes within the hour, they'll issue a special report. And that special report means just if I hear on the ATIS information that they're issuing a special report, that there's new information available and it's a special report, that means something major changed. It either got majorly worse or majorly better, but there was a significant change recently. Prevailing visibility, what's the visibility all across this area or all across the airport or runway complex? That might not be the visibility that I'll have right there at that runway. Some of these airport complexes are large. There's miles and miles and miles between the control tower and the runway that you might use. Runway visual range was established to address that exact problem. The control towers up there, they say, you know what, I can't see anything outside. We're going to call it half statute mile visibility. Well, maybe they could see just fine at the runway. Now there's very, very little human interface. This is automatic. That's automatic. A human looks at it to make sure that it wasn't an error. And if there was no error in it, it gets disseminated automatically. And that's automatic as well. The runway visual range happens from machines. So all of this stuff now is communicated to flight crews automatically through the use of machines. Ceiling. Last night I mentioned to you guys that we'll talk about ceiling when I was talking VFR over the top. And I said as a student pilot, you can't climb above a ceiling. Well, of course not. Look, there's something in the way. Not this ceiling. but a cloud ceiling. What is the cloud ceiling and how do we define it exactly? There's a slide in here that'll take you through the 8 slices of a sky pie and what will make up a ceiling. Okay? Radar weather reports, pilot weather reports, a PIREP, terminal aerodrome forecast. This is your 24-hour out forecast, and it's only for that exact airport and 5 statute miles. Why do they go from nautical to statute miles? I don't know. Who knows? Makes it even worse.
Inches and feet.
Because inches and feet and all that. Well, you know, so when you're doing visibility, by the way, all visibility is in statute miles. And I don't understand that either. I live over there. I don't understand who said 5,280 was a magic number of anything. Anyways. So yeah, that's how far away that terminal aerodrome forecast or that TAF is. 5 statute miles away from the runway complex. Winds and temperature aloft forecasts. We started just a little bit talking about how this airplane is affected by wind. Okay? My relative wind, does it have anything at all to do with these winds aloft? Does my relative wind have anything at all to do with winds aloft? Okay, I see some shaking of the heads, and that's the correct answer. That's good. But I expected everybody to shout out with a loud and roaring no. Okay, remember, relative wind is relative to what? Motion on the airplane. Who cares what's going on with the way this atmosphere is moving? So just for right now, this entire room is just the entire state of Florida, right? And maybe the wind is moving rapidly here, okay? If I'm moving this way and my airspeed indicator shows 120, I'm going 120 through the air. But the air is going over the floor here at another 10 knots or 15 knots, okay? So I don't care what's happening with the winds aloft when I consider performance en route, when I consider my relative wind and aerodynamics. But when it comes to calculating how long I'll be in the air, I need to know what are the winds aloft, because I'm trying to go from one point on the ground to another point on the ground. So be able to figure out and think in your mind, are we adjusting this for the wind and the atmosphere moving across the ground, or is this strictly an aerodynamic problem? Okay, winds and temperatures aloft forecast. These are pretty accurate. We used to use flight computers. We're going to use flight computers. We got a room full of flight computers. We got a handful of them over there. If you download the flight computer app on your iPad or iPhone, we can use those too. That's what I use for demonstrations. But we have flight computers and we can use that. Doesn't take a battery. It's awesome. It's great. The screen won't break because there's no screen. You can use these to determine a lot of information about your flight by consulting the winds and temperatures aloft forecasts. At the same time, kind of another little nugget or another little token of information, if I use any of the flight plan application tools, flightplan.com, 1-800-WeatherBrief has one, 4Flight, there's a lot of different tools. It will automatically do those calculations for you. So we're almost there. You know, when we start into navigation and planning a flight plan, you know, one of the questions that come up from pilots, and a very, very valid question, you know, questions that I get from you guys that make sense. I love those questions, but a good question is, why am I planning this flight from here, from Fort Lauderdale Executive to Naples, and it's a 55 nautical mile trip, and we've spent 4 hours planning, okay? Because if you don't do it that way, and you just go to the flight data apps, and you just let the computer constantly tell you the answer, you'll have no idea how the answer was developed. And if the answer ever needs to change while you're flying because now you're changing directions and you no longer have an internet connection, it's nice to have the knowledge, the background knowledge on what that computer was doing to figure that out. So no, you won't do that every single time, because if they did, the airplane market would have been closed a long time ago and people would have been driving instead everywhere. But you gotta do it a few times just to figure out and get that background knowledge, and then you go to the computers. Okay, so that's winds and temperatures, aloft forecast. Hurricane advisory, is there one coming? We'll know about it for a long time before it gets there. Convective outlook. 3 things that are needed for a thunderstorm. What were they? Unstable conditions. I needed what else? Unstable conditions. What else? High humidity. I didn't need to be saturated, but high humidity. And some sort of a lifting force. Convection is a lifting force. Yeah, so get used to it. If those 3 things exist in that region, the weather forecasters are going to issue a convective outlook. Okay? Remember, I told you from March until mid-September, October, you have the entire southern peninsula of Florida and all the way out into the Caribbean covered by a convective outlook. Okay? If you didn't accept any risk at all ever, then you would never fly. Heck, you wouldn't have driven the car to go to the airport anyways, right? You got to accept a little bit of prudent risk. All right, severe weather watch bulletin? No. Now, severe weather watch bulletin, just like me, when I was sitting on the ground that day and we had tornadoes coming through Tampa, and the drunk guy's trying to ask me if we could fly anyways and maybe we can climb over it. No, my friend, it doesn't work that way, right? All right, alert severe weather watch? Of course not. Airmets and SIGMETs, useful tools that will describe over at least a 3,000 square foot area what kind of weather exists that's hazardous to my flight. Think AirMet as moderate. There's nothing light about either one of these two, but AirMet is moderate, and SIGMETs are going to be severe. Okay? And then a convective SIGMET. Same type of thing. It's severe. It's something very hazardous to all flight crews, but it involves convection. It involves some sort of lifting force. I can associate that right now with thunderstorms. All right, back to the top. We go to METAR. What kind of report is a METAR? It is just an hourly observation. This is all weather that has already occurred. But how long ago was the maximum time frame that this occurred? 1 hour. So this is prudent weather. And I can download 3, 4, 5, I can download 36 hours worth of METARs, and I can get an idea of what's happened in the past and how does that trend look, right? Which way is the weather going, better or worse? Okay, it's going to start off with a METAR, tell you what kind of report it is. If there were severe changes to that weather, or some sort of significant change to the weather, and it wasn't yet the top of the hour, then they would issue what's called a special report. And here, instead of saying METAR, it'll say SPECI, because they only got 5 letters for that block. It's just going to say SPECI. Anybody in here do any programming on Fortran? If I say Fortran, does that make sense? You guys are going to like a little bit of this, okay. Yeah, a little bit? Oh, man. Yes. The most I've had in a class in probably 10 years. That's cool. All right, station identifier. Where's this? Tampa. The K means is ICAO for something in the U.S., and then TPA is Tampa. If I don't know what station identifier it is, I can look it up. Chances are likely I programmed whatever weather reporting service I'm querying for that specific airport. So I probably know what the airport identifier is. Time of report. This is what's called a date-time group. So the U.S. does things that's kind of screwy with date, month, year. I don't even know which way to go, and it constantly changes. But date, time group, always with the FAA, you're going to have the date, as in the day of the month, and then the time. and then it's Zulu. Florida right now, we are 5 hours behind Zulu. Once we change the daylight savings time, if we do that again this year, they talk about it every year that we're going to stop, and why? I just don't know. But well, eventually, it would be -4, okay? If I didn't know that information, by the way, where would I find it? If I didn't know my GMT offset, where would I find that information? The ugly green book, every time that has everything in it. Okay, all right. Now, modifier is not shown. It just will indicate if it's an automated report or a corrected report. That's fine. It's not always there. No big deal. The next one is your wind. This wind is listed in true direction at 080 at 20, gusting to 38, and it'll have a KT at the end for knots. Okay? Visibility. The first one will show me in statute miles, and it will remind me statute miles with an SM. And then if there's runway visual range, I'll see that it's RVR for runway visual range. This reads 36 left, so runway 36 left, 2,400 feet visibility. Okay? So the prevailing visibility in this area is 1/2 statute mile. The runway visual range is 2,400 feet. Let me just spend a little bit of time. Let's get outside for a minute and look around, okay? I'm going to spend a little bit of time on runway visual range. Number one, the chance of you using this at all until you're an instrument pilot is nearly 0, except for on a test. Okay? The chances of you using this as an instrument-rated pilot, unless you have something that costs several $1 million that you're flying, is probably very slim. Okay? So if you don't fully comprehend runway visual range, I wouldn't just give up on flying right away. Okay? But let's try. Runway visual range is similar to the prevailing visibility on the airport, except it defines only the visibility at that exact runway. And there are sensors. And the sensors, there's actually 3 of them. Oh, God, it's terrible. At the approach end, in the touchdown zone, and beyond the touchdown zone during the rollout. And this will allow me to understand exactly how much visibility a pilot can see from a moving airplane from the flight deck as it makes the approach. Okay? So it's some sophisticated equipment. It's a whole lot more accurate and more precise than the prevailing visibility. All right. Over here I get a weather block. Something about the weather. In this case, it has a plus next to this. And the plus means heavy. If it was a minus, it would be light. But keep in mind that believe it or not, there is no such thing as a heavy thunderstorm or a light thunderstorm. Okay? There might be a thunderstorm or a severe thunderstorm, but there's no such thing as a light thunderstorm. There's no such thing as a heavy thunderstorm. So what I have here is a thunderstorm and heavy rain. That's how this one reads. Get ready, because if that one was hard to swallow, just wait till we get to winds aloft. Okay? All right. There's a scattered layer of clouds at 800 feet. That scattered layer of clouds does not constitute a ceiling. In other words, student pilot, I can climb over 800 feet. I just have to keep my VFR requirements met. Overcast at 1,200 feet. And then it says cumulonimbus. Now, something that's peculiar, something that's interesting about forecasted reports, terminal aerodrome forecasts, or TAFs, every time you have a thunderstorm listed for the forecast, how many times do I say every? Not many. I'll say almost every, or just about, or with. Every time on the TAF, if you have a thunderstorm here, you'll have cumulonimbus in the cloud forecast. Okay? Can't have a thunderstorm without the cumulonimbus. For the TAF, they'll always get those two together. Temperature dew point, 2018. That's in degrees Celsius. What do I expect here? What's happening? Low clouds or fog. That's right. So if this is in the afternoon and the sun is going down, I have a feeling that it might get foggy soon, because I know my temperature is probably going to decrease. I got a pretty good amount of wind that might keep those clouds up high. But if that wind was really light, I would certainly expect some fog. Okay? Altimeter setting, A, this is in inches of mercury, so 29.92. And then welcome to this life called remarks. And some of the remarks don't even apply to flight crews. So if you got a remark on there that is 503418, that's just something that's a code by which forecasters talk to each other. It does have a meaning with pressure, temperature, or pressure falling or rising within the previous 3-hour period. But it means nothing to us. All right? All of these things have meaning. Some of them don't have a specific meaning to pilots. Some of them do. How do I know? Advisory Circular 00-45. My friend, it's only 453 pages. Okay? All right. Remarks. Thunderstorm began at 24 minutes after the hour. And the rain began at 24 minutes after the hour. Well, here's my valid time. So 21:50, it was 21:24 when that thunderstorm and rain began. Okay? Sea level pressure is 1013.4. How did I get it? Magic. Okay? You just take these digits, slide them that way, stick a 10 in front of it, and put a dot right there. I don't know how else to tell it to you. What does this mean to me as a pilot? It means that if I'm using this, I probably need to go to the altimeter shop and buy one with inches of mercury, because that's the way we're going to share information about QNH or my altimeter setting. But it's on there. It's on there. My South American crews will come over here and they got that. I don't understand. Okay, let's go on. Coded data. Let's take a look at some explanations. If there's all zeros on the wind, it's wind calm. 200 at 14, easy. Look at that. What's this next one say? Don't look over here. What degrees are the winds coming from? 150, okay. 10 knots gusting, 25, pretty easy. Look at this, variable at 4. What does that tell me? Which direction is it coming from? They don't know either. Yeah, who knows, right? And then when 210 at 210 at 103, gusting 130. Good Lord have mercy, where are we at?
Maybe go home.
Yeah, maybe getting a storm shelter, right? I guess I didn't realize that they snuck that one in on me. I always update my slides as soon as the new books come out, but wow, okay. So a fair question to ask on this is, if I were taking off from runway 170, what's my crosswind component? Oh, I can't wait for tomorrow. It's going to be fun. We'll come back to that slide. I'll have to save that one. Okay, look, here's prevailing visibility. 2 miles visibility right there. There's the observer's location. But out here, I have 4 miles of visibility. So they're taking the least amount whichever direction they can take and using that as your prevailing visibility. If I wanted first of all, if I'm flying here, I'm maybe in and out of VFR conditions, right? Because 4 miles, I'm VFR, 2 miles, I'm not. Special VFR, is it day, night, am I in class golf? Oh, geez. If there's a square root in this, we need to just stop and, like you said, go home, okay? But if I were flying in this as an instrument-rated pilot, I'd have to consider, what's my runway visual range? This is a condition where I'd say, what's the runway visual range on that runway 12? And if I don't have runway visual range, well, I know I have at least 2 statute miles visibility. Can I make an approach? What kind of approach is available? We'll talk all that in the instrument program, okay? This particular airport, I'm not flying in there. And by the way, if it's daytime at this airport, what do you think would let me know that we have less than 2 statute miles as I drive up to the airport? Daytime, if the rotating beacon is on, you have less than 3 statute miles or less than 1,000 foot visibility. Basic VFR minimums are not met. So if it's daytime and the beacon is on, you guys know which beacon I'm talking about, right? The rotating white and green beacon. If it's daytime, the white and green beacon is on, yeah, there's 2 statute miles visibility, and that's why I don't even need to listen to the forecast. I can just go right into the parking lot, turn right back around, and go back to the Dunkin' Donuts, right? All right. Or it could mean that the tower controller just forgot to turn the light off. No, I'm just kidding. I've seen it happen before, but you could tell the difference there. Okay, here we go. Some descriptor codes. We had that TS. Remember the thunderstorms? Look at some of the other ones. I love the mist, and I recently found out, after however many years that I've been flying, something new the other, probably 2 weeks ago. Thunderstorm, showers, freezing, blowing, low drifting, shallow, patches, and partial. Okay? So these are all descriptor codes. Let's continue on and say some weather phenomena codes. This is rain, so freezing rain, right? Blowing drizzle, right? Some descriptor codes on those. Snow, ice crystals, unknown precipitation, some of the, not that the human didn't know, because the human will probably know, but some of the computer systems that are used to gather the weather information aren't equipped to determine what type of precipitation it is. Very few. Most of them are the AO2 type weather observation devices. Some of them, even though they are the AO2 weather device, that function could be in disrepair. It could need money. It could need some repair. And they would put on there a little $sign to say, this one needs repair, for whatever part of it is broke. Okay, hail greater than 1/4 inch. Small hail or snow pellets, snow grains, and ice pellets. That's types of precipitation. Obstructions to visibility. Fog, mist. Oh, I love this one. Smoke, haze, spray, sand, dust, and volcanic ash. How in the world am I supposed to remember mist? Good gracious, that's 2 classes in a row that's told me that's broom? Is that what it is? Look, for 29 years of flying, I had no idea. And I can tell you exactly how I teach everybody in the United States to remember mist. And it's not just me. I got this from somebody else, and a lot of places use it. Mist is baby rain. I didn't know it was broom until this last class I had. It was all Russian students in there, and I've asked the same question for years. And I've got the same dumb looks from everybody in the room. And I said, okay, fog, that looks pretty easy. What about mist? How am I going to remember that? It's baby rain. Oh, that's funny. Well, I guess this is a real thing, broom. Okay, other weather phenomena. Squall, dust storm, funnel cloud. Tornado or water spout. Difference in these two. That one's over land, that one's over water. Sandstorm, dust and sand whirls. So as I go through and look at the METAR, if I find information in this METAR that I'm not familiar with, I can go to that slide, I can go to the book, or Advisory Circular 00-45. If you download that one online, by the way, and go to the table of contents, the table of contents is hyperlinked to the actual contents. So go in there and find observations, METAR, click on it, it'll take you to all the descriptor codes and everything about that. It's pretty nice. Okay, do I have a ceiling or do I not have a ceiling? These 8 slices of the pie is the answer. These are the answer. So from an observer's point of view, they look all the way to the left and all the way to the right and form one solid line segment. Then divide it in 90 degrees like this and cut that into 4 equal slices on both sides. Weather observations will make a determination on how the sky cover is reported depending on how many clouds are listed or how many clouds are visible in each one of these octants. Okay? So each one of these 8 slices of the pie, each one's an octant. If I have 0 octas covered, well, the sky is clear. 0 to 2, few. All the way to a half, I have scattered. All right? Once it goes over a half, but it's not completely covered yet, that's called broken. And completely broken is completely overcast means every one of these have some sort of a cloud visible by the observer. In this case, the observer is a human being. There aren't too many human beings that do this any longer. It's observed by some sort of an optic. Sky clear, few, and scattered are the only ones where I can say I do not have a ceiling. If I have a broken layer or an overcast layer, that means that we have a ceiling. And if the ceiling is reported below 1,000 feet AGL, you do not have basic VFR. Okay, some more coded data. AO2. Just a moment ago I was talking about precipitation was unknown. Well, it didn't have an AO2 automated station. Any kind of automated station with an AO2 observation station has precipitation discriminator. It can tell the difference between rain, hail, snow, sleet, whatever the case is. So you won't get that precipitation unknown remark. Here I got peak wind, 200 at 32. It happened 25 minutes past the hour. That one's interesting. Visibility, 3/4 mile variable to 1.5. Frequent lightning to the northeast. Oh, God. Freezing drizzle began 45 past the hour. Rain ended 42 and snow began at 42. Pressure falling rapidly. Sea level pressure, you can see how you did here. 10.4.5, right? And then temperature dew point. A lot of times it lists it. This gives me a more accurate temperature dew point. All right, so we're 2 degrees apart, but am I 2.5 degrees apart or 1.7 degrees apart? So here it is. It looks like I got a negative on there, right? Yeah. So temperature, 0.1 Celsius and then negative 1.6 on the dew point. Okay? So it just gives it to the most accurate temperature dew point. Here's some METARs. It's practice round. There's another translation for this, and that is Pensacola Automated Radar Weather Report. This is a radar weather report, but it's also at a naval air station. When I tell you you're not going to see one of these, you're just not going to see one of them. Okay? And if you do and you don't know what to do with it, So it's a radar weather report off of one of these naval air stations. Okay. In 1935, Zulu, line of echoes, average 10 coverage, thunderstorms, 10 rain showers. What do we do instead? We look at a radar summary report, or you actually look at the radar on one of these screens. Now, I don't get this information in an airplane that doesn't have FIS-B. I don't get this information on my screen. So I could receive one of these reports. The problem is there's very, very, very few of these reporting stations. I don't even know that NAS Pensacola does it anymore. All right, but it is something that's out there and it could be available.